Question 3e. What we need to do with question 3, we need to think about the first part of the question and how we actually generated our tree diagram. Your maths teacher gives you a multiple choice test on probability. Each question has 5 choices, of which only 1 is correct. You have a 60% chance of knowing the answer. Otherwise, you guess at random from the 5 choices available. So the original tree diagram will look something like this. You get your question. Okay, do you know how to answer it or not? That's the first question you're going to answer. So you've got a 60% chance or a 0.6% chance of knowing the answer, and then you're going to get the answer right. If you don't know the answer, then you're going to have to guess. There's a 0.6 chance of getting it right straight away, and a 0.4 chance when you're going to have to now go into guess. Now, if you guess, you're just taking a potluck. So when you guess, you can either get it right or you can get it wrong. So the chance of getting it right if you're just guessing, each question has 5 choices of only which 1 is correct. So you've only got a 1 in 5 chance of getting it right, and that means you've got a 4 in 5 chance of getting it wrong. Now you might want to change this to a decimal, just so that it's easier to do future calculations. So that's 0.2, and that's 0.8. So that's how you set up your tree first of all. When we come down to part E, we have another multiple choice test. So this time we're going to do the same kind of thing again, but a different test. You have probability P of knowing the answer. So this probability isn't 0.6, it's now P. And that means your chance of not knowing the answer is going to be 1 minus P. In the same way, to get 0.4, we had to do 1 minus 0.6. You find you get exactly half of the questions correct. So the way that you got the correct questions correct, or right, the way that the probability that we got the questions right in the original problem, either we could go up here, 0.6, or, that's why we add them together, we could have gone along here, we could have guessed and got it right. And to guess and get it right in the first numerical example was 0.4 and 0.2, so that's those two things multiplied together. Now we're looking at the probability that we get it right, but we're looking and they're telling us that exactly half of the questions are correct. So they already tell us the answer is 0.5, and we've now got to work out how to get there. What are the 2 possible sets of values for P and C? C. There are C choices for each question. So in the first question, there were 5 choices for each question, and we had to write 1 over 5. And now we have C choices, the probability of getting it right is 1 over C. And this was all the other ones. So there was a 1 out of C chance of getting it right, but then there was a C minus 1 chance over C of getting it wrong. Okay, so for example this was 5, and that's 5 minus 1 is 4. So now we've written the probabilities in terms of P and C. So you find that you get exactly half of the questions correct. So we know that the answer is 0.5. What are these calculations we need to do using P and C now? So the 0.6, which we had in the original number, is P. So I might just write it down here. 0.5 is equal to 0.6 now is P plus the 0.4 relates to this line here, which is 1 minus P, and that's being multiplied by the 0.2, and the 0.2 is now 1 over C. So we have to solve this problem. So all we can really do is that we can just try out some numbers and see whether it works out. Okay, so let's just try out if the probability of getting it right was 0.6, what's going to happen? So we have 0.5 plus 0.6 plus 1 minus 0.6, which is 0.4, times 1 over C. So this must give us an answer of 0.5 equals, So if we try and solve this, we're trying to find the number of answers that we'll need to have for C, the number of choices. When we try and solve this, if I minus 0.6 off both sides of the equation to start off trying to isolate the C, we're already into the negatives. That's not possible. Okay? In fact, any number here has to be less than 0.5, because when you start taking it away, it's going to become negatives. So P must be less than 0.5, or it's not going to work. Okay, let's just try a different number then. So now let's try P equals 0.3 and see if we can work out the value of C and see if that works out. Okay, so the probability is altogether going to be 0.5, and now we're going to put in 0.3 instead of P. So we've got 0.3 plus 1 minus P, so that's 1 minus 0.7, the 1 minus 0.3, which is 0.7, times 1 over C. Okay, let's work this out and see if we can come out with a value for C. We minus 0.3 off both sides of the equation to start off with. So 0.2 is now going to be 0.7 times 1 over C, so it's just like over C. Let's just check out what we do. We can use our formula triangle to see how to find C. 0.2, 0.7 and C. So to find C, we're going to have to do 0.7 divided by 0.2. So C is 0.7 divided by 0.2. And that gives us 3.5. Now 3.5 is the number of choices. You can't have 3.5 choices. C has to be a whole number. Okay, so C must be a whole number. So this option is not going to work. Okay, let's just try another value for P. Let's try P is equal to 0.4, and this is all you can do, is keep on trying to see whether it works out. We know P must be less than 0.5, so let's try this one. So 0.5 is our probability. P is now 0.4 plus 1 minus P, which is 1 minus 0.4, which is 0.6, times 1 over C. So first of all, we're going to minus the 0.4 off both sides of the equation so that we end up with isolating C. This is 0.6 divided by C. Okay, using our formula triangle again, we've got 0.1 equals 0.6 over C. So to find C, we have to do 0.6 divided by 0.1. C is 0.6 divided by 0.1, and if you calculate that, 0.6 divided by 0.1, the answer is 6. We have a whole number now. So it appears that we have a solution that will work. And all you can do is just do trial and improvement. So the probability could be 0.4, and the value of C, which is the choices, can be 6.